When we were last in Zoom together, we did a couple of examples of finding derivatives using the limit definition of the derivative. I'm going to do a couple more of those in this video for you today. So here we're going to find f prime of 1 for f of x equals root x plus 3. So I'm going to copy down our derivative definition. F prime of 1 is going to be the limit as h approaches 0 of f of 1 plus h minus f of 1 all divided by h. All right, so just like in class, we're going to evaluate those two things up at the top. Again, it's using that function twice. So once here and once here. So let's evaluate f of 1 plus h. So our function is square root of x plus 3. So we're going to have square root of, replace the x with a 1 plus h plus 3. And then we'll do the same thing for f of 1. We're going to take the square root of 1 plus 3, right? So let's go ahead and simplify a little bit and put this in the limit. So we have the limit as h goes to 0. I've got 1 plus h plus 3, that's going to be h plus 4, or 4 plus h, however you want to write it. And then minus square root of 1 plus 3 in green there, square root of 4, that's actually just equal to 2. And then over h. And as always with the limit definition of the derivative, if I tried to plug in h equals 0 right now, I'm going to get, let's just go off to the side and do that. I'll get square root of 0 plus 4 minus 2 over 0. I'm going to get that 0 over 0 indeterminate form. And again, that is always going to happen with the limit definition of the derivative. We are always going to need one of our limit tricks to bring this home. So let's go ahead and clean the slide off and do our trick. In this case, our trick is going to be to multiply by the conjugate up top. So I'm going to multiply by root h plus 4 plus 2. And so we don't change the limit. We're going to also multiply on the bottom by root h plus 4 plus 2. And up top, that's going to be a FOIL. So I'm going to put some parentheses here. And let's also put one down here. All right, so I'm going to FOIL out on the top. We're going to do our first terms. Don't forget your limit. So we're going to say the limit h goes to 0. Root h plus 4 times root h plus 4. That's going to be root h plus 4 squared. Then we're going to do our outer terms. That's going to be plus 2 root h plus 4. Inner terms, we're going to multiply negative 2 times root h plus 4. So minus 2 root h plus 4. And then our last terms, negative 2 times 2. That's going to give me minus 4. And then on the bottom, we're going to leave this h just multiplied in parentheses. Remember, our goal is to cancel out that h with 1 on top so that we can get rid of that removable discontinuity. So I'm not going to distribute it. I'm going to leave it like this. All right, and as always, stuff cancels. We've got the plus 2 minus 2. That's the whole point of rationalizing, so that the stuff in the middle drops out. And then let's do our simplification. So always writing your limit as h goes to 0 until you're done. Let's see, I've got root h plus 4 squared. That's just going to be h plus 4. And then the only thing that I have left up top is that minus 4 at the end. And then I got this big mess down here. So I've got h times root h plus 4 plus 2. And then we can see where this cancellation is going to come. These 4's go away. And I've got the limit as h goes to 0, h over h times the big stuff. All right, and finally we get that 0 over 0 to drop out, and we're ready to take our limit. So all that I've got left up top is a 1. And now I'm ready to plug in h equals 0, and I'm not going to get something undefined. So I'm going to get 1. I'm going to get square root 0 plus 4 plus 2. Let's see, so that's root 4. That's going to be 2 plus 2. And we get 1/4. All right, so let's do one more example of finding the derivative using the limit definition. So we're going to find f prime of 3 for f of x equals 4 over x minus 5. All right, so we'll copy down our limit definition. So we've got f prime of 3. It's going to be the limit as h approaches 0, f of 3 plus h minus f of 3 all over h. All right, so again, let's evaluate our two function boxes here. We've got f of 3 plus h. So I'm going to go up to my function, 4 over x minus 5. That's going to be 4 over 3 plus h minus 5. And then we'll do the same thing for f of 3. F of 3 is going to be 4 over 3 minus 5. And we'll just plug those in and simplify a little bit. All right, so we're going to have the limit as h goes to 0. Let's see, the blue box, 4 over 3 plus h minus 5. That's going to be h minus 2 down in the denominator. So I'm going to have 4 over h minus 2. And then I've got 4 over 3 minus 5. Okay, my green pen up here, this is 4 over 3 minus 5 is negative 2. Okay, so this is just negative 2. So we're going to have minus a negative 2, so plus 2 all over h. And there are lots of different ways to simplify that complex fraction. The trick I showed you was to multiply through by the common denominator. So I'm going to multiply top and bottom by h minus 2. And that's going to clear out that denominator. So we're going to distribute an h minus 2 to the fraction and to the 2. So I've got limit as h goes to 0. We're going to have that 4 over h minus 2. We're going to multiply that by an h minus 2 plus 2 times h minus 2. And then we'll apply one to the denominator as well. So h times h minus 2. All right, and we do that so that this h minus 2 goes away. All right, and then let's see what we've got left. So we've got the limit as h goes to 0. We've got a 4, that's all that's left of that first fraction that was there. And then I'm going to distribute this 2 to the h and the negative 2. So I get plus 2h minus 4 over h times h minus 2. And again, I never distributed that h in the denominator because I'm hoping I'm going to get to cancel it out to get rid of that 0 over 0 that we know is going to be there. And here's where we get to do it. I've got 4s that cancel out up top, and I've got the limit as h approaches 0. I've got 2h over h times h minus 2. And now that 0 over 0 drops out for me, and I'm ready to take the limit. All right, so limit, I can plug in h equals 0. I've got 2 over 0 minus 2. 2 over negative 2, just equal to negative 1. All right, in the next video, we're going to take the two derivatives we've done in this video and use them to find tangent lines.